evening, everybody. And on behalf of Mills and Reeve, I'd like to extend a really warm welcome to all of you at Cambridge AI. For those that don't know me, I'm Vicky Lynn. I'm a corporate partner here at Mills and Reeve, where I head up the 16-strong venture capital investments team. Our VC investments team lawyers are spread across our offices, and we advise startups, spin-outs, entrepreneurs and scale-ups on their incorporations, their investment readiness, their fundraisings from pre-seed and seed through to late-stage Series A, B, C and beyond, as well as their growth transactions. And we also work with many of the investors who fund those sorts of businesses, so institutional venture capital funds, CVCs, corporate venture capital, family offices and business angel groups. So it's not a particularly interesting slide, but it's just giving you some facts and figures about our firm, for those that don't know us. We have 170 partners, 1,250 staff, and we're based in 7 offices. So outside of Cambridge, we're also in London, Norwich, Oxford, Birmingham, Leeds, and Manchester, which gives us a truly national outlook and business. We've got really strong sector focus in technology and life sciences. I sit in both of those sectors, and we are immersed in the regional clusters and ecosystems within which our offices are based. So turning attention now to AI, we're really fortunate here in Cambridge that we've got one of the most successful technology clusters in the world. And in what has been a really challenging VC investment environment over the last couple of years, I think it's fair to say that AI investments have been what's really largely propped up the venture capital funding community, both in the UK and Europe, and also in the US. Latest figures show that UK AI startups raised $2.1 billion in Q1 of this year, and are on track for a record-breaking year, with the sector projected to raise $4.4 billion by the end of this year. So that's the UK. In the US, AI investments saw a 47% increase in the first quarter of this year, from $37.8 billion to $55.6 billion. So I'm really looking forward to listening to our speakers today and on what's really exciting deep tech growth sector. I'll hand over now. Have a nice evening, everyone.
How do we... Are we on? Good evening, ladies and gents. I'm Daniel Bone, Senior Consultant here at Robert Walters. First and foremost, thank you everybody for coming out tonight. Welcome to Cambridge AI. For those of you that haven't been, it's a bi-monthly event, which I've been corrected on tonight. That means every other month, not twice per month. So we're going to be going every other month for this event. So just a quick little bit about myself and Robert Walters. So we are a global PLC recruitment agency. We cover tech, we cover finance, we cover legal, we cover supply chain. You name it, we probably will cover it in some way or another. And in particular, data and AI, we have a massive focus on community-led events. So obviously this, and then my colleague Tom, who sat over there. Tom, raise your hand. He runs our Manchester AI user group. We run a number of different ones across the country. A little bit about myself, 5 years in tech. In terms of my current remit, I cover Cambridge, cover Oxford, and little bits of London as well. So if you're looking for a job, looking to hire somebody, looking for some market information, please feel free to reach out to myself and I'll see what I can do. In terms of roles that I typically recruit for, you can see there, I'm not going to go through them all. Pretty much anything in the world of data science, AI, machine learning, or bioinformatics. And in terms of events that we've got coming up, so we are going to be doing an event focusing on investment into early stage startups and scale ups. So if you're interested in that, call me afterwards and I'll give you some more information. We're going to do a roundtable with data science and AI leaders. And again, Cambridge AI is going to be in November, following on from this one as well. So very close to finalising that. As always, all the details will be on the meetup page. So let me pass over to Mark, my co-organiser for this evening, and take it from there.
Thank you very much, and thank you very much to Ziki for hosting it, and to Daniel for co-organising it. We started this event from Grounded AI. Grounded AI are a local startup. We're remote, few of us in Cambridge. We're looking at mostly around citation checking in academic journals. So at the moment, we'll have something to show about that soon. We're working on a really interesting product called Veracity, which checks citations. So if anybody wants to investigate that more closely, come and find us and our colleagues. Nick's down there in the audience, and we can show you a sort of cheeky early demo of that. Tonight, I'm delighted to welcome our speakers, and they are Tom Whitehead and Sacha Krstulovic. I'll say a little word about Tom. He's going to be up first. So Tom Whitehead is he heads machine learning at Intelligence here in Cambridge. He has a PhD in theoretical physics from the University of Cambridge and specializes in the practical applications of machine learning in industry. Tom works closely with R&D teams in the materials, chemicals, and manufacturing sectors, applying intelligence technology to accelerate innovation, with particular application to high-value data analysis bottlenecks. So, Tom, take it away. Tom's going to talk about milkshakes.
So, good evening, guys. Thanks very much for coming along. Thanks for the invitation from the organisers. So my name's Tom, and as the slide says, I'm going to talk about milkshakes today. So before we get to that, who am I and why am I here? So my name's Tom, Head of Machine Learning at Intelligence. Who is Intelligence? We're a Cambridge-based machine learning spin-out from the University of Cambridge. We spun out 6 or 7 years ago now. And we focus, as Mark said, mostly in the materials and chemicals sectors. So we help our customers develop better materials, chemicals, food and beverage products, manufacturing processes, you name it, we'll help them optimize it using machine learning. And the bottom point we've got here on this marketing slide, which I am contractually obliged to include, is that we focus on the ease of deployment, the ease of use of the machine learning. We don't want machine learning used by people who only know Python. We want machine learning used by people who know materials and chemicals and milkshakes. And we want that to be as easy as whatever other tools they use as part of their day-to-day business. So that's about intelligence. What are we going to talk about today? We're going to start with the froth of AI and what I mean by that. Then we're going to focus on some of the value within that and how we extract it, and finish up with a quick case study. All opinions are my own. I'm going to say some stuff you are going to disagree with today. So I look forward to being corrected in the questions afterwards. So if I ask you to think of AI, what do you think of?
ChatGPT.
ChatGPT. Thank you. Skynet. I didn't put Skynet on the side. I guess any Google fans in? Gemini, Anthropic. Was that longer as the next one? Oh.
Leonardo.
Nah. I mean, there's quite a few, right? What do they all have in common? Language models. These are all large language models, right? And these are what people think of at the moment when they think of AI. And that's because of the sort of bandwidth that's out there to talk about AI. These guys, they've got 90% of it, 95% of it. This is what people are talking about at the moment. And this is what I mean by the froth of AI. So this is a visual metaphor of bubbles appearing on a slide. I love a visual metaphor. The froth of AI. So we've got a huge amount going on in the AI space. These guys have value. We're going to talk about the value that it's bringing. Definitely is there. But there's a lot of other stuff going on as well. And I want to dig down on some of those bits that are generating real value, generating ROI. That was the title of the session today. And how it works. So, as I say, these are all large language models. They generate lots of value. LLMs are awesome. If you want to accelerate coding, I guess quite a few of us in here code every day. Quite a few of us in here probably use large language models every day. I use ChatGPT. I'm learning a new coding language at the moment. It's brilliant. If you want to summarize documents, I know there's people in the audience whose business is based on this. It's amazing. You put in information and you can summarize it in a quick, easily digestible format. You want to generate content. If you're doing marketing, you've got existing content, you want to quickly generate a social media post. Brilliant. Natural language interfaces, if you want to be Scotty from Star Trek and speak to your computer, so I can see who got the first contact jokes there and is old enough to remember Star Trek. But yeah, if you want a natural language interface and you're fine with it maybe not being the most responsive at the moment, but that'll get better, they're brilliant. If you want the answer to a question, if you want to basically have a new cool Google, large language models are brilliant. If you don't mind that the answer might be different tomorrow if you ask the same question. If you want to translate between languages, these could be human languages, they could be coding languages. Again, if you don't mind, you're only going to get 90 or 95% of the way there. So when I'm doing the coding that I use ChatGPT for, yeah, it gets me 95% of the way there. That little bit on top normally needs a little bit of human inputs at the moment. And if you want quick analysis of text or data, again, there's people in the room whose business is based on this, so it won't be too mean. But if you don't mind that occasionally the insights that it's going to get there are just going to be making stuff up. So when I say making stuff up, I mean taking stuff from its training corpus and applying it as though it's applicable to your data set that you're currently working it on. That's sometimes fine. Sometimes it's less fine. So these are brilliant things that you can use large language models for. Really useful, get lots of value from them. But what if I want to make a milkshake? Visual metaphor. We have what is the closest I could get to a milkshake at short notice. How do I go from not having a milkshake to having a milkshake? So I can ask a large language model. I can ask it, what's the best way to make a milkshake? And it will tell me. So here's some examples, a few different models and what outputs they would give you. And you can see actually how they've been trained slightly differently to give slightly different types of response as well. And this is fine if I'm going to go to my kitchen and make a milkshake. I can follow these instructions. Awesome. No problem there. And then if I go and do it again tomorrow, it's going to give me a very slightly different answer. It's going to slightly change it. And again, if I'm me going to my kitchen to make a milkshake, that's completely fine. It doesn't matter. If I'm a large multinational corporation trying to make milkshakes or trying to design the best milkshakes, that's not okay. We need that there's consistency and we need stability, reliability, etc. when we're working on these sort of large deployments. So at the commercial scale, these large language models, they often lack a bit of specificity on what we're working on, unless you do massive amounts of fine-tuning, in which case you're going to need to do it all again in 6 months' time when the next good model comes out. That's its own problem. And also, we've talked about large language models. They can make stuff up, they can hallucinate. In the industries that we work in, regulated industries, that can be a safety issue. So, for example, we're making milkshakes, and we've got an idea that we're going to ask the large language model, what's the formulation of this milkshake I should make? 999 times out of 1,000, completely fine. That one time out of 1,000, it remembers back in its training data about all of the milkshakes that have ever been seen, and it thinks colorant E171, that's a brilliant colorant, it will make it nice and white, maybe you're making a vanilla milkshake, awesome. But about 5 years ago, E171 was classified as carcinogenic, or possibly carcinogenic, I should say, in case anyone knows more than I do. So you really probably shouldn't be putting it in your milkshakes. If you've put it in 1 out of 1,000 milkshakes that you're making, your company is going bust because people are going to find out about it, and you've killed some people. Those are not so good when you're trying to have that maintainability in large scale. And as I say, repeatability and traceability are important, especially in a regulated industry. So our customers, the problems that our customers are trying to solve are design a new product, a new milkshake, that has the right properties. For a milkshake, it has to be the right color. If it's a vanilla milkshake, it does have to be white. If it behaves the right way, it's not too foamy. We don't have too much froth in there. It uses the right ingredients. Again, not too many ingredients. We don't want too many stabilizers. We don't want too many ingredients in there because they get expensive. We don't want too few because then the products don't work properly. And we don't want to include that E171 because it'll give people cancer. And it has to use the right processing. I don't want to go and buy a whole new bit of kit for my factory just because the AI said, oh, it might be 1% better. I want to use the bit of kit I've got in my factory. I'm not spending tens of millions to upgrade it. And it has to cost the right amount. Everything that we do in industry costs real money. And they have relatively fine margins compared to a lot of the people in the tech space. So that all needs to be optimized. Also, it has to taste good, because otherwise nobody will buy it. So our customers have a really specific set of requirements. They need something very precise that satisfies really precise requirements that they're trying to achieve. And I've just said that large language models are not good at this. So why am I here talking about AI when I've just said AI is no good? Because there are other sorts of AI that we can dream of beyond large language models. So this is fundamentally a data problem. So people have data on milkshakes. These guys have been making milkshakes for decades, possibly even centuries. They've got lots of information about it. They know things sort of in the knowledge of the company, in the memory of the company, what has worked, what has not worked. They have these very specific requirements, which can all be, almost all, numerically classified. You can write down the requirements that people need to satisfy in an equation, which artificial intelligence can solve. So it is a data problem. And in my opinion, and I hope probably in most of yours, artificial intelligence is the right way to solve large data problems, potentially on unstructured or semi-structured data. Artificial intelligence is the right tool for that job, but not necessarily large language models. We have very precise requirements. It's very process-driven. When you're making things at scale in manufacturing, you do the same thing day after day. If one day a large language model comes along and says, but do this other thing, it's just not happening. You need something that's consistent and driven by that process. We tend to work with R&D organizations, so people who are coming up with something new. We talked about the idea that large language models, they're really good at understanding their training data. They're often very good at interpolating within that training data, identifying relationships and then filling in the gaps. R&D, by its definition, is something new. It's outside the range of training data. That's often something that can be quite hard. And fundamentally, the question we're trying to answer is, what experiment do I do next? Which milkshake do I go and make next? What we need is old school ML. Bringing it back, multi-layer perceptrons, random forests, Gaussian processes. These actually generate value today and have been doing for years. I know they get lost in the froth, but they do exist there, generating value. The way we do that is this adaptive experimental design approach. You start with data, you collect data, you train a machine learning model on it. That guides future experiments that you're going to run, gather more data, take it to a lab. Someone has to go and physically do experiments, collect that data and feed it back in, and you get a virtuous cycle of more data feeding where the best data is to collect to improve your process. And what we find is this typically requires 50 to 80% fewer experiments than our customers found using their traditional approach. That right there, that's your ROI from machine learning. 50 to 80% fewer experiments, that translates directly to cost. So I'd now like to quickly run through a very quick case study. I'm going to get told off for time shortly, I'm sure, but I'm going to run through run through a quick case study of how this works in practice with a company called Yearly. Anyone in the audience recognize the name Yearly? Yeah, well, yeah, you do, you work with them. So if we were giving this in other parts of the world, definitely you would recognize it. They are one of the biggest dairy companies in China. They're the most valuable dairy brand in the world. Think of a dairy brand like Arla, probably have heard of. These guys are about 10 times as big. And they serve 1.1 billion consumers annually. I like being able to put the word billion on a slide like that. That's quite impressive numbers. But what that means is that they do need consistency. And a 1 in a million chance impacts 1,000 people. You can't take those risks in the sort of industry that they're working in. So what we were doing with these guys was looking at a long life dairy product. So this dairy product needs to be as good 9 months later after it's been sat on a supermarket shelf as it is the day that it was originally made. That's the main objective they're looking for. It also needs to give a good yield. So when you're creating it, it can't be too much air, it can't be too foamy, it can't be too frothy, to bring back a theme. And then it has to behave well. When you whip it up to try and make a whipped cream out of it, you can't spend 10 hours trying to whip it before it works. Fundamentally, this is a formulation process, formulation problem. We've got a set of ingredients. What do we put in there? We've got some cream, we've got some stabilizers, we've got maybe 10 that we could pick from. I want to use 2. Which two do I use? How much of them do I use? There's a lot of combinations there. If you do the combinatorics, if you've got, I don't know, 10 stabilizers and 14 emulsifiers, and you want to use a total of 3, maximum of 2 from each of them, there's a lot of combinations there. How do we solve that data problem? I think that's where the machine learning comes in. What we're trying to do with those ingredients, obviously we're trying to get a good milkshake, dairy product. We're trying to find the right ingredients that are going to achieve that good performance, minimize the cost, minimize the embedded carbon. In this case, that was a big objective for these guys. And then once we've got those ingredients sorted, we need to apply some processes. So we need to stir it, we need to homogenize it, we need to pasteurize it. All of that costs time, all of that costs money, all of that costs carbon. Can we reduce all of that? And those have a feedback within them. So if you use a set of ingredients, you have to use certain processes, and they all feedback. It all needs optimizing simultaneously. And at the end of the day, we need good properties. It needs to be a nice milkshake. And it needs to maximize that shelf life. It needs to work well. So this is the data we had to go with. I know you can't see this. I've just put some random black and white bits on a slide. But what we had was about 1,500 data points. So they'd measured 1,500 historic milkshakes, which they have, they've been measuring for the past few years. And they provided us information on those. The inputs, fairly easy. The ingredients, they use different ingredients, they use different stabilizers, they use different emulsifiers, etc. The process was actually kept fairly consistent in this example, so we didn't have to worry about it too much. But then the outputs is where it started to get a little bit complicated. So they were measuring multiple properties of these long life milk products, in theory, once a month. So you go to the lab once a month, take the thing off the shelf, measure its stability and how foamy it is and whatever other properties we were interested in. That's brilliant in principle. What happens when, we try and take this data and we're halfway through? So some of them have gone for 5 months, they're not finished yet. Okay, we'll start with what data we've got. Those ones that have been running for 3 months and the milk had gone off, they're not going to keep running the experiments for another 6 months so that we've got a nice data set for us, our artificial intelligence to work with. Okay, they just stopped. Those of you who do clinical trials or work in the clinical area might recognize some of these problems. Inconsistent sampling. So it's meant to be measured every month. Guy went on holiday, so we measured it after 6 weeks instead. We need to take account of all these real-world impacts or real-world problems when we're working with it. And what we can see over here on the right, this is going to be tiny for the guys at the back, sorry. Where there's black, there's data. Where there's sort of these white sections, it's just missing. We don't know why it's missing. Might be because they stopped early. Might be because they haven't finished yet. We don't know. We have to deal with either possibility and just deal with what we've got. And that's why we turn to our marketing slide. No, sorry, our in-house Alchemite machine learning model. So this model is designed to handle those gaps in data. It's designed to handle both very small and fairly large data sets. There's 1,500 rows of data that we had. That's really big for a milk company. They've got to measure lots of bits of milk to generate that. But it's actually really small on an AI scope. I think everyone in here would hope that you've got a bit more data than that to get going with. So we need a system that can handle these small data sets. And to bring back the point from earlier, we've got this, we hope, intuitive UI. We've got a UI designer in the audience, so I better say it's intuitive, but it definitely is. It's a good way for non-data scientists, so people who don't know what Python is, people who think a Python is a thing in a jungle, they can get access to the benefits of the machine learning without having to know how to code. They click some buttons, they ask questions in the scientific language, get answers in the scientific language, and don't have to worry about really what happens behind the scenes. And it includes this experimental design workflow that we talked about. So how that worked in the yearly project was, at the start of the project, we had that initial data, so that 1,500 rows. We used that to train a machine learning model using our Alchemite approach. We then guided them on some new experiments they should try. So we, I think, proposed 10 new experiments, 10 new milk products that they could go and make. We gave it to their chemists, well, their chemists generated them and had a look at them. They really liked 5 of them, and they really didn't like 5 of them. So if I was writing a funding application, that would be reinforcement learning through human feedback, that we're getting feedback on what they like and what they don't like. Those ones that they did like, they took to the lab, they tested them, they fed them back into the model, and we went around this cycle, only a couple of times in this case. And they ended up with a really great product that the customer was really happy with, and a lot fewer experiments than it would otherwise have taken them. The particular outcomes they were particularly happy with were actually not the product itself, but the insights they got along the way. And here we come back to that interpretability and the traceability that perhaps is sometimes missing. That they were able to determine important ingredients, so what really makes a difference to their milk product, but more importantly, the ingredients that don't make a good difference, the ones that they can drop and stop thinking about and stop keeping in stock because they're no good. That made a real difference to their lives. And then another interesting one was unexpected cross-correlations. So they've got, say, 2 ingredients that on their own, yeah, they both work really well, give a good positive impact. Put them together, they interact, it's all horrible. Everything goes wrong. It's really hard to identify those in a traditional experimental design approach. Interactions are difficult to capture, but machine learning is able to pick it out from existing data. That's really valuable. And then this down here at the bottom is a global dairy conferences. There are global dairy conferences. And a guy at Yili was very kindly presenting with our name on it. So I was super excited about that. And then down on the bottom right, it says Yili releases its first AI packaged milk. So brilliant marketing opportunities as well as brilliant products that are being generated. And just quickly, one last slide that I have to throw up is you might have thought, okay, AI can design a milkshake. Okay, I don't make milkshakes. This is applicable in lots of areas. We work with all of the people on the board there, solving lots of different problems, lots of different industries. I have to stick NASA on there because who wouldn't? It's really cool to say you work with NASA. But that's pretty much it. So in summary, we've talked about that there is lots of hype, there is lots of froth in AI at the moment. There is real value. It is being generated. It has been being generated for several years now, generating those new products more quickly and more efficiently, generating real value for our customers and others. Thank you.
Does anyone have any questions for Tom?
What are you doing with NASA then?
Right, it is rocket science. No, so it was heat exchangers. So you need a heat exchanger that fulfills several properties. You know, it's got to be light, it's got to be efficient. And the way that the AI came up with it was it decided to put a fan in it because then you get loads of airflow through it. I mean, they didn't want a fan in it. They gave that as an option that maybe it shouldn't have had. But yeah, definitely was gave them some insights.
Well, follow up on that. I mean, how different are the application areas and how much bespoke work do you end up having to do to actually meet these applications? If you say you've got some single purpose software and set about to just work, I mean, that sounds like a very different formulation than the milkshake problem.
Yeah, so if we abstract it to the level of, I think I had ingredients, processes, and outputs, we can abstract many problems to that. And we have one bit of general purpose software that works for a lot of those. So the NASA case, there weren't really any ingredients, but there were lots of processes. What shape is the heat exchanger? Does it have a fan in it or not? They're just variables then. The same with the ingredients in the milkshake. They're just numerical or categorical variables. The machine learning doesn't care what the labels are on it. We're not putting in external knowledge. We're taking everything from the customer because then it's only got the right knowledge. It can't make stuff up. So it is very general purpose, especially nowadays we can just stick things in and go.
Yeah. Do you think AGI can eliminate those hallucinations you were talking about, or is that irrelevant because the the machine learning models that you've got?
So if we get to AGI, I think many of us are going to be looking for different jobs. It would definitely help with some of that. So the hallucinations is not such an issue for the sort of machine learning approach that we have because it only uses data from the customer effectively. It's siloed. It can't learn outside that.
Where do you think we possibly are with that AGI kind of status, if you like?
So you saw my first slides. I'm
Is that a bit looking forward, maybe a bit much?
So I think intelligence is a strong word for artificial intelligence at the moment. Okay. There we go. Now we've got disagreement. So yeah, I think it's really valuable tool, brilliant statistics that's gone into them. Intelligence, yeah, we'll see.
Watch your space and yeah.
One. So in your organization, do you guys mostly stick with these classical machine learning models like random forest and all that, or do you use stable diffusions, deep neural nets? What's the split there in terms of the application?
Yeah, that's a good question. So
Design involves a lot of generative AI. So
yeah,
it's,
so there are different approaches to material design, some of which are really heavily generative models. We tend to stick on the more old school Bayesian optimization for the actual optimizing part of it. The model that sits behind that and generates the forward predictions, we do use different things. So we do use a lot of random forest Gaussian process, old school stuff. LSTMs, anyone remember LSTMs? They were cool once. They're still really good for the problems that they're designed for. It's picking the right tool for the right job. And in our job, that's not general language models.
And there was somebody at the back there.
I noticed you drew a comparison between machine learning and traditional experimentation in that the value gained was additional insight in correlations. Is that comparison the same, would you say, between machine learning and large language models?
So between how we'd use them in sort of the applications we focus on?
If we're able to.
Yeah, I think that is one of them. I think that's probably one of the main distinguishers. The reason that we like the more classical approaches is you can understand what they're doing. More importantly, our customers and their regulators can understand what they're doing. Another is that trust factor, that it can't do something quite as crazy. I know people are putting guardrails on large language models all the time, but there's still that risk factor, which maybe in a few years people would have worked out a better way of dealing with it, and we won't have that problem.
There is a hybrid here where rather than treating it on all the text on the internet, you just train it on your own stuff based on parameters and simulations and things like this, and experimentation. But you also allow language tokens.
Yes.
The same way as you have language tokens with like pieces of music or something, which have all the same sort of language structure, but aren't going to be human readable.
Yes.
You just get it to generate its own here.
Yep. We do. You've caught something that we do that does use large language models. So often in these data sets, you'll have like a notes field, like this worked really well, or this didn't work at all.
But not in plain English, in the tokens it's generated from the type of data you've given it.
So the type of data we work with is normally basically in a spreadsheet. You can imagine it as a spreadsheet. People have trained language models that are based on that structure. Mambula is quite popular at the moment, if anyone's is talking about that, state space model. But that's, they don't tend to work quite as well for the just basic predicting things, given an input, what's the output going to be? If you're trying to get semantic information out of a notes column, for example, we do like things that can extract semantic information from that, encode that in some way, and then give that on to the other tool. That's definitely something that we get lots of value from.
Thank you very much. I think we should thank Tom for his excellent presentation, and he will be available obviously in the bar to ask more detailed questions afterwards. So our next speaker is Sacha Krstulovic, who runs Understand AI Today, which is a consultancy helping businesses turn AI into valuable products. Do you want to set up the... it's already there, is it? Fantastic. That's it. Sacha began researching speech technology at Toshiba and Nuance, directing R&D at Audio Analytic, which was acquired by Meta, and was director of AI at Music Tribe. Sacha loves the creative aspects of technology and entrepreneurship, and on weekends you can find him practicing music with his 3-year-old son. So Sacha, welcome.
Thank you very much for the kind introduction. Oh, okay. Years of, Anyway, all right. Thank you very much to all of you for coming tonight, and then thanks to Grounded AI and Robert Walters for organizing this, and to Mills and Reeve for the hosting. The theme tonight was ROI from AI. This talk is called AI, How, What, Why, Mind the Rhymes. We were probably feeling in a poetic mood. I'm Sacha Krstulovic. I'm an AI researcher who gradually became a manager of technology. When you start in AI from the technological angle, you're in love with the algorithms, you're in love with the stats, you're in love with the data. And then with time, if you make a business out of it, or if you help people to make business out of it, or you contribute to a business in some way, you discover that, well, you need to innovate, you need to keep your things fresh, so you need to keep being a researcher at some level. You need to turn technology into products. We'll come back to that during this talk. You need also, you discover that your 2 arms and 2 legs aren't enough, you need more arms and more legs, so you start hiring people, training them, working with them and so on. And then intellectual property as well, so working with lawyers such as Mills and Reeve to kind of file your patents and so on is also one part of the job which I really enjoyed as I grew as a manager of technology. Now the sort of canvas of this talk, that's going to be the most complicated slide of this talk, but then we're going to come to simpler things, is this notion of road mapping, or what are the roots between the technology and business. So when you do AI, so you have a technical capability essentially. So say, as a simple example, AI can recognize pets, or new AI can generate language. But then that is just a technology capability, it's not a product. So from the AI, you need to define products and services. So in that case, a cat recognizer version 2, or which could become, with a bit of innovation, the pet recognizer version 1 in the future. And then you could make a software as a service platform or API for pet language generation. All of that is products. But then you don't do products in the void, you do them to serve business objectives. So you could have objectives which are to remain competitive, for example, in the cat detection market, if we take that as an example. You might want to strengthen your market position, or you might want to form a sort of complete kind of business offering. If you think of Apple, for example, they don't do just the phones, they do the calendar and so on. So platform play, digital ecosystem, and other business models. And of course, to do all of that, you need resources. So you need engineers, compute servers, data, or specialized people, and so on. That is known in sometimes in other terms as the why, what, and how of what you're doing. And it's important to have all these things kind of connected. And the route between the technology and the business via the product can go both ways. It's as useful to say, hey, did you know that this new AI could do this and that and that, and therefore would you be interested in doing a business model around that, as to say, in order to remain competitive, we need an AI which does this and that and that and that. When I say AI, I mean machine learning in general. I mean something that looks intelligent that's based on machine learning. I don't necessarily mean LLMs. We in the previous talk we became aware of the pitfalls of that. So the gist of this talk is let's keep the arrows connected and in both directions. That's how we make value from AI. Is how we make these connections effective. Now I'm going to invest 3 minutes of my precious talking time asking you guys what you think is the biggest AI pitfall when you make business of AI. What is specifically makes AI a different product or a different thing from? Are there any stories from you guys of what works, what doesn't?
User suspicion.
User suspicion. User suspicion is a good one. Yeah. But if we remain within the business, what makes an AI business work or don't work?
Clients data before, like you can generate a really great model.
Yeah.
And some companies can have insanely unrealistic expectations given really terrible data they put forward.
Yeah.
They want like really good outputs. And
customer.
Data-driven code.
Yeah.
They want their outputs.
So customer expectations and time frames and I suppose data requirements around that, of course. Yes.
Cost of processing, depending on the size of the models, or the
could be the cost of processing. Okay, yeah. So those are good. Those are mostly external factors. So what we're going to look at is our internal factors to the AI business. Does anybody know Hans the horse? So Hans the horse is a horse who could do mathematics. You would ask the horse how much is 2 + 2, and the horse would go. And people would go, oh my God, this horse can do mathematics. Well. And this gentleman here with the lab coat is Oskar Funkt, who studied what the horse was actually doing. He spent quite a long time kind of experimenting. What is this horse doing? He can't be doing mathematics. And what he concluded is that the horse was actually picking on the reactions of the audience when he was like coming close to the solution. People go, and the horse was actually detecting that. And so an analogous story, you probably heard about the tongue detection story, where people were trying to make a tongue detector, and then when the weather changed, that whole tongue detection completely stopped working because it was detecting the color of the sky rather than detecting the tongues themselves. Now, those things are real. So there is an article from a fellow researcher called Bob Sturm. Seeing his works really changed my life, literally. The article is called The Horse Inside. So he was analyzing the music genre classification systems. And there were lots of papers published in that field at the time, and he took one of the standard data sets that people were using to rank their systems in terms of genre detection. He just changed the tempo of the different tracks in that data set, and the whole performance of genre classification became completely messed up. A slow waltz is still a waltz, but then it was classified as something else because the system was a tempo detector rather than being a music genre detector. So the lesson from that is it's a horse until proven otherwise. Whenever you make AI, you need to be really, really thorough with a couple of things. One is evaluation metrics and testing methodology are super crucial. And beyond that, you need to be aware of confirmation bias, be adversarial. Don't test only the true positives, also test the false positives. I remember one of the war stories is radar detection system where a supplier was contracted to supply that detection system, and the acceptance criterion was it needs to detect X% of what he is supposed to detect. And there was nothing about the false positive, so the thing was detecting everything. Yeah, of course it detects. It detects also the stuff that it's not supposed to detect. But yeah, so you get the idea. The other thing is avoiding horses isn't only the machine learning engineer's problem. Why is that? Well, first of all, data is costly. So if you don't have data for your testing and for dispelling the myths or to be thorough about what your system is doing, you can't really prove whether it's a horse or not. And data needs support from the business. There is a huge point of return on investment on investing in data, not just on the engineers and the brains and the models. And data itself must represent the application's field conditions, and that needs support from the product management, because product management knows what the product is supposed to do, knows the specifications and so on. So you need to be testing the right thing. So we have those three personas, which are the business, so C-level investors. Then you have the product management, and you have the AI engineering. What is it that they talk about? So if the business goes, just make it work, I don't care how, sometimes it's good, it's just, you guys know better, you have the brain the size of a planet, you know best anyway, just make it work. I will give you $2 million, please make it work, I don't really want to know how. Or if your product management is also a bit like, AI is complicated, I'm not sure if it works, but the engineers will tell me if it's doing what it should do. And then the engineers are like, nobody understands what I do, and I told you guys that this was not going to work. If that's what your three components talk about, your three personas talk about, you have a phenomenon of divergence. Everybody silos themselves in their own kind of culture, rather than this, where you can talk about something else. So the business and C-level can be talking about the budget and support needed to make the AI working. What do you need to make it work? What can you achieve with the budget that we have? How is also it's very important for the C-level to foster the vision and the connection with the business strategy. So this is what we're trying to achieve. How is this AI system supporting? So actively encouraging the rest of the organization to connect the technology with the higher level business. It doesn't mean that people are going to be different, are going to have different skill sets, but it means that they talk about these things. At the product management level, feasibility, understanding the boundaries of what the AI can do is really important. So users would like to do whatever, recognize cat. Can AI do that? Or if it can't do that, what else could it do that is close enough to what we're trying to achieve? There is also a notion of cost of errors, which is very important to manage at the product level, which is what is the best way to address the errors which impacted user opinion. So some errors are not all equal. When I was at Audio Analytic, for example, the glass break, if we were missing a glass break because that was indicative of someone breaking into your house, that would be a lot more costly in terms of reputation and opinion about the product than if we would have, for example, a false positive about something crashing on the floor. Of course, we were optimizing for both errors, but their weight in user opinion was not exactly the same. Then at the level of AI engineering, so applied statistics are important. So when I say applied statistics, I mean what is really happening in the field. Academic data sets might not be what you want for a product. What is it? What are the prior probabilities of what's happening? How much of what is happening when, and so on. We'll come back to that. And then also the push-pull. So by definition, this AI cannot do X, but would be okay if it did something else instead. So with that, we are into that discussion and negotiation and mutual kind of understanding, which is a form of convergence, which leads to success. So best practice to achieve that convergence. Again, if we take those three personas of the technologies, the product manager, and the business manager or business in general, so the how supported by the engineers and the researchers, it's important to understand the domain, the field conditions, and the statistical priors. So this, why did I put a bird? So when I was at Audio Analytic, we did at some point a deployment in various houses of our sound detection system around the world, literally. And one of the things we were doing was detecting smoke alarms. And one house in France, in the back of France, had a ginormously huge amount of false positives. And we discovered that they had a bird, like a maynard or something, or a form of parrot, which was hearing the smoke alarm and started to imitate the smoke alarm. And therefore, that was generating a humongous amount of stuff that there was one house generating something that we really didn't want to detect. So sometimes those things are unexpected. The scope of the reason why we're using machine learning in general is because there is lots of stuff that we, as humans, we can't even imagine are going to happen. We would never have thought about that bird. So it's important to have ways and methods to get insight into the field data. And the product managers are going to support you with that. So that, which leads to the next thing, which is upskill your product managers, but also learn from them in the sense that help the product managers to understand the importance of the statistics in the field. And it's really difficult for the human brain to understand the notion of prior probabilities. For prior probabilities is, for example, X% of people will have a dog at home versus some people don't have a dog. So if you're trying to do a dog bark recognizer, for example, you might tune the statistics of the presence or absence of a dog, depending on what happens. Or even better, you can put a button which says, do you have a dog? And then you switch off the dog recognition if people are not interested in that. So, and that goes via the product managers. And in that sense, product manager, you need to help the product managers to understand the statistics. It's hard, but it's not impossible. Just train them on that, but also learn from them in the sense that product managers usually come with a wealth of knowledge about specifications, about, they are your ears and eyes in what the customers want and what's happening in the field. So you need to listen to your product managers as much as you help them to understand those complicated notions of statistics. Then as technologists, so the engineers and researchers, you are the custodians of feasibility, and stick to your guns, be clear. Elephants don't fly. Whenever someone would ask me to do an AI where I was 100% sure that it wouldn't work, I would say, look, not sure because out of belief, but sure because I know the math and the statistics and the stuff behind it. And by definition of what it does, it's never going to do that. That I call that a flying elephant. So, well, you don't need to be conflictual about it, but what you need to say is elephants don't fly, but elephants can be very strong and they can walk a very long distance. So would that be good if we did that instead? But you can't get persuaded as a technologist that elephants fly, and you need to really claim your expertise in that domain. And then the final thing is learn to speak value rather than tech. As technologists, we are often in love with the technology. We love our LSTMs, our transformers, or all the math that goes in this kind of thing. But it's interesting to speak value rather than tech. So the school book example is the iPod, where you can say it's got 2 gigabytes of memory, or you can say it can hold 2,000 songs. So it's more intelligible to the rest of the business, to your product managers and your management and your business management, if you say, if you speak about the value of what it's doing. It's good at dogs, but it's I don't know, it's better at smoke alarm, or whatever the case is going to be. But learn to speak value rather than tech. When it comes to the product managers, so the what. So it's important to enforce user experience metrics and bridge them with AI metrics. So this complicated curve is a area under curve of a detection system. So that's what scientists and researchers and engineers use to measure how many detections the system performs. But there is a complication about that, which is the number of false positives versus the false positives are related to the true detections. So depending how sensitive you tune the system, it could be making more of one, less the other, or you could balance the system differently. That's very, very far away, and that's system data set dependent from the 5-star system that Amazon uses to rate products, for example. And Amazon uses this 5-star system to rate their own internal products that they make. It's not just the thing that you find on their website. Whenever they make a new technology or a new feature for their marketplace, they rate it with stars, and they don't let something through unless it's 4.5 stars minimum. And that's a user metric. So the role of the product manager to a large extent is to match the user metrics with the lab metrics, because lab metrics are not going to be good user metrics, or user metrics are the ultimate test, but they're more expensive than actually the lab metrics. What I recommend usually is a pipeline of 3 types of metrics. You have so what I call lab metrics, which are what you get once you train a system to see if that system 2 does better than system 1. Okay, if it has soaked more information from the data, then you can simulate some things. So for example, for the sound detection system, we built a whole anechoic facility to play back some sounds with a very, very high level of realism that was more costly than lab metrics. But still, that would give us some answers. And then at the end of the day, the user experience was the biggest seller. Was that the kind of finish time? Anyway, then as a product manager, again with the help of the engineers, understand the field statistics, the priors, the biases, the type of errors. So priors is the likelihood that something is going to happen. Biases, you're all familiar with that notion of the face detection system having at some point been biased towards white skins because there was not enough black skins in the training data set. That's a bias. Type of errors. So the true positive and false positives are one type of error, but in detection systems in particular, you also have when one sound is detected for another, which is a type of error. So it's important to connect that, to understand what type of errors the AI does, and to connect that again with the user metrics. And then as a product manager, I'm an advocate of saying that you should own, influence, and plan the data collection and labeling. Don't just let the engineers do that. Work together on defining that. But as the product manager, as someone who's got insight in the field, you are the one in the best position to go, hey, we're going to go here, record this data, or we're going to get this data from here and there, and to organize the data collection, because at the end of the day, that's the material that you're going to need to make the system better, to put relevant data in the system, but also to assess that to ascertain that your system is not a horse, essentially. Then the why, business owners. So it's important to understand the cost of AI, especially the data assets. That's most of the projects are tanked because the amount of required data is kind of underestimated, or there is a push because data is expensive. There is a push towards saying, well, can you do it half the data instead? And so there is really, again, it's a dialogue thing about understanding how much data is needed. Now, there's the positive side of that is also that data if you own your data, if you have a brilliant data set, so to an extent, the success of Audio Analytic and the acquisition by Meta was because the data set was mint. There was not a single thing that was scraped. We had the ownership of everything. So it's part of the return on investment is taking those investment in data questions seriously. There is this question of should you make or should you buy? Should you have your own internal AI team or should you outsource that? If you choose to outsource, you should probably have at least someone inside able to interpret and guide your provider to check that things are going well. If also part of the value of your business is to create your own intellectual property, then you should do it in-house rather than outsourcing. So there is, depending on the case, is one or the other, but you should do this analysis of ownership value versus outsourcing risk. And then corporate responsibility is usually the responsibility of the business owner. So freedom to operate and ethics. Don't let your team go scrape dodgy data because as the owner of the business, you're the one who's going to get sued if that is wrong. So try to get in the detail with your teams about where the data comes from and do you have really the freedom to operate, and also licensing of the models and all of that. And then the ethics, of course. As a business owner, you want your system to do some good. It's important to try to forecast what's the AI going to do in the future, and again to be a bit adversarial, but also to build a defensive position on some of these things right from the get-go. To say, well, look, we guarantee. So remember when Google was we doing no evil, for example. But it's important to build a defensive position with the help of lawyers, actually, on what you're going to do with your system and where your data comes from. And then overall nurture trust with your engineers and your product managers. As the business owner, you're the one who is conveying a clear and shared vision. And that clear and shared vision is something that also you, it's not something that you throw at people. It's something that you kind of tune. It's like leading an orchestra, and then everybody going to that same note, but not in a coercive way, in a way that is, you're really trying to get buy-in. So this is the portrait of Captain Cook. How did that guy manage to build to bring a boat of people go around the world like this, like in the middle of the ocean? Well, probably he was a very good leader going, this is where we're going, this is why we're doing that. Are you guys in or are you guys out? And most people would get excited by, hey, we're going to find some, special islands and stuff like that. And we're going to make those maps. Maybe there was excitement about innovation in Captain Cook's crew. All right, so summary and key points. Your AI is a horse until proven otherwise. That's really, really important to do the testing thoroughly. Everybody's involved across the how, what, why. It's not just the machine learning engineering team that's responsible for the data, the errors, and so on. Everybody has a part to play, and especially via the data. So in that sense, understanding the data priors in the field is hard, is really hard, because it's this thing where anything could happen and so on. So you need methods in place to sample the data. You need things in your product. For example, if you can capture data via your products, it's a very good way to understand the data priors of what's happening in the field. It's hard, but it's necessary. And then linking AI capability with a clear user story and a corporate strategy. We don't do AI in the void, and it's important to have a vision. We don't just, I want AI. Well, okay, but why? Because we want to be more competitive, or because we want to improve this and that efficiency, reduce cost, all sorts of business incentives, which AI is really good to solve. I'm Sacha Krstulovic. I'm running Understand AI today. I'm really happy to help with that kind of question. It's good sometimes to have an external look of what you're doing. So if you want me to help with any of what you're doing, just please talk to me during the drinks. Thank you.
Thank you so much, Sacha. That was a great presentation. Now we're at time, but we've just got time probably for a couple of quick questions before drinks. So if anybody has a burning question, we can do that now. So,
hi. Maybe you can give some insight into where you've had to facilitate the debate around the ethics of the AI, and I'm thinking more about not so much about the workflow and collecting data, but more about where the output might be used or might not be used, where where it could lead to some unintended consequences way beyond the horizon when somebody's really pushing for the commercial output?
Yeah. So thankfully, because AI is a hot topic, the law has moved a lot on that. So there are some guides. So GDPR, for example, is good as a framework to make sure that what you're doing with data is ethical and legally compliant. The EU law about AI is also really good because it's not framing the algorithms themselves, but it's being fairly clear about the usage which are ethically damageable to society. So they're also a good analysis grid. So you can find this. You can use that as kind of canvas to do your ethical evaluation of what you're doing. Then it's domain dependent.
Thank you very much. I think we'll follow up in the bar afterwards, if that's all right. So I'd just like to thank very much our hosts, Mills and Reeve. We had a lot of help setting this up from Zicky, Sarah and Josh. So thanks very much to them for hosting the event this evening. We're going to follow up in November. Look out for that. Thanks to Robert Walters for laying on the hospitality this evening. And thank you then finally to our two speakers, Tom Whitehead and Sacha Krstulovic.